All right. Hey again, Honors Chemistry. I wanted to do like a couple of practice problems following the procedure I had mentioned in the previous two videos about getting empirical formula and then getting the molecular formula. So let's do a couple of examples here. You'll get this practice in class 2 and it'll sound familiar. So let me do A. So it says calculate the empirical and molecular formula for the following percentages of elements and molar masses of the molecular compound. So remember, the steps from our notes are, if I have the percentages, I assume that we have 100 grams of sample, that I convert the mass of each element to moles by dividing by the molar mass. I find the smallest number of moles and divide all of the moles by the smallest number of moles, and I round to the nearest whole number, and I can make like kind of like subscripts out of those whole numbers. So let's do that for this example. So I have 50.7% carbon, 4.2% hydrogen, and 45.1% oxygen. Later on it says the molar mass, and this is for the molecular compound, is 142 grams per mole. Let me just figure out the empirical formula. The percentage data always gives me the empirical formula, okay? The percentages always give me the empirical. Empirical means experimentally determined from data, and you always get the empirical formula. So remember, the first step is turn these percentages into grams. So I'll have 50.7 grams of carbon, I'll have 4.2 grams of hydrogen, I'll have 45.1 grams of oxygen. Okay? Then the next step is convert these grams to moles by dividing by the molar mass. Okay? So now what I'm going to do is I'm going to divide by the molar mass of carbon, which is 12.01 grams per mole. Carbon. I'm going to divide by the molar mass of hydrogen, grams per mole, hydrogen. Oxygen's about 15.999 grams per mole, oxygen. And these are going to give me the moles of each of these elements, right? So I'm dividing the mass given to me by the molar mass. Remember, mass divided by molar mass is equal to moles, okay? So I'll do 50.7 divided by 12.01, and I get 4.22 moles of carbon. If I do 4.2 divided by 1.008, I get 4.17 moles of hydrogen. And if I do 45.1 divided by 15.999, I get 2.82 moles of oxygen. And now this is my smallest moles. The next step is dividing all of them by the smallest moles. And remember, I like to write like a fake formula. So C422H417O 2.82. And now between these three, my smallest moles is 2.82. So I'll divide by 2.82, divide by 2.82, divide by 2.82. 4.22 divided by 2.82, I get C 1.5. 4.17 divided by 2.82, and I get H 1.5, and then I'll get O 1. Okay? Now, I didn't mention this in the other video, but usually we would round this to the nearest whole number. I'm gonna see if we I'm going to try and have us stick with that for now. And then, let's see. No. So, if you have something that's like 0.5 or 1.5 or 2.5, you have to multiply that by 2. This is going to be like new rule, right? I didn't mention this in the previous video. So, if I want to get the empirical formula with anything with 0.5s, I have to multiply by 2. So I'll get C3H3O2. And look at that. That is an empirical formula. Empirical formula. And the molar mass of this empirical formula is, let's see, plus 3 plus 32. The molar mass of this is 71 grams per mole. And the molar mass of my molecular formula is 42, which is twice as much. So if I want the molecular formula, I have to multiply that also by 2, and I got C6H6O4. That's my molecular formula. Okay? Now, I wanted to show you this as just a side example of something new. If I ever get 0.5, it's hard for me to round up or down because it's kind of like in the middle. So I always have to multiply by 2. That's a new rule. I'm not going to give you too many of those. Let's do another example. Let's do 40% carbon, 6.6% hydrogen, 53.3% oxygen, and the molar mass is 90. All right, so I'm going to automatically divide these by the molar masses. I'm skipping steps. I know this is, I'm going to assume the percentages are equal to grams. So 40 divided by 12.01, I get 3.33 moles of carbon. For the hydrogen, I'll do 6.6 grams of hydrogen divided by 1.008 grams per mole of hydrogen. And I get 6.67 divided by 1.008. I get 6.61 mole of hydrogen. And then for oxygen, I'll do 53.3 grams of oxygen divided by 15.999 grams per mole oxygen. 53.3 divided by 15.999, and I get 3.33 moles of oxygen. Okay, now again, following the same procedure, percentages become grams, grams become moles divided by because I divide by the molar mass, and now I'm trying to divide by the smallest moles. Now I have 3.33 and 3.33, so I could divide by either of them, right? So I'll give my fake subscripts: 333, H6.61, O3.33. I divide by the smallest moles to get whole numbers, and you can see what this is going to look like. I will get, as my empirical formula, CH2O. This is my empirical formula. Okay? So, this was me doing a couple more examples of using that procedure. I take the percentages, I turn them instantly into grams. Then I take the grams and divide by moles. And then I divide by the smallest moles by all of them. And that's going to give me my formula, right? This 3.33 divided by 3.33 is 1. 6.61 divided by 3.33 is 2. 3.33 divided by 3.33 is 1. 1, 2, 1. 1, 2, 1. That's how I use these ratios that I get, or dividing by the smallest number, to give me my subscripts in my formula. Okay, so I'm hoping this video has helped set you up for this, for the next couple of problems that I'm going to make you do, and we're going to go over this the next time we meet in class. So it's very important that you know how to get percent composition, and then it's very important that you know how to get empirical molecular formulas from percent composition.